Now let's try this problem based on geometry. Here, find AD if radius of the circle with center O is 2 root 3 and CE is 2 centimeter and CB is tangent to the circle at P. That means this must be 90 degree because the angle between radius and tangent is always 90 degree. So this angle is 90 degree and ED is diameter. That means this angle will also be 90 degree because that is angle in semicircle. Now we can make three relationships. The first is this AB square plus BC square is equal to AC square, right? And AB square is what? AB is nothing but diameter. Diameter will be 4 root 3. So AB square will be 4 root 3 square that is 48. So this is 48 plus BC square is equal to AC square. The next relation is, see, BC is tangent and CA is secant, right? BC is tangent, CA is secant. So you can recall this tangent secant theorem, that is BC square is equal to CE into CA. CE into CA or AC, or CE is actually 2, that is given. So BC square is actually 2AC. Right? So instead of a BC square, I can put 2AC over here. So that's AC square minus 2AC minus 48 is equal to 0. If we can factorize, that is AC minus 8 and 6. So AC minus 8 and AC plus 6 is 0. So AC will be 8. Right? So BC square is equal to 2AC. So 2 into 8, that is 16. So we got AC, that is 8. AC is 8, CE is 2, that means AE is 6. Now BC, we don't actually need. ED, we know that is 4 root 3. Now this angle is 90 degree. This is hypotenuse. We can put up the Pythagoras theorem. So that is 48 minus 36. So that's 12. That is AD. AD square, so AD will be root 12, or we can say 2 root 3. Okay, so I hope you are clear. Now let's try this problem of geometry from SSC CGL 2013 paper. D and E are 2 points on the side AC and BC respectively of a triangle ABC such that DE is 18 cm, CE is 5 and angle DEC is 90. If tan angle ABC is 3.6, then AC is to CD is what? First of all, I just draw a diagram, a rough sketch over here. This is my triangle ABC and this is angle DEC, that is 90 degree, right? So this is A, this is B, this is C, this is D and this is E, right? This angle is 90 degree, that is given. DEC is 90 degree. Now what? We have to find out the ratio AC is to CD. AC is to CD, right? Now what I do a small construction over here. I just draw a line over here. That's a perpendicular from vertex A to side BC, and this is suppose P, right? Now triangle CDE and triangle CPA, both of them will be similar. Why similar? Because this angle is 90 degree and this angle is 90 degree, right? And this angle is common between the two triangles, right? So triangle CDE, I just write over here. You don't have to write in the time of your exams. You just have to save the time. CPE. And the reason, angle C is common between both the triangles, and this angle is 90 degree and this angle is 90 degree. So this is AA similarity, right? Now CE is given to be 5 and DE is given to be 18, right? Now if the two triangles are similar, the sides will always be in proportion. And 10B, that is ABC, 10 angle ABC is given 3.6. So actually 10B is 3.6, okay? Now the sides will be in ratio of both the triangles. So if this is 5, this will be 5x. If this is 18, this will be 18x. Okay. And we have to find out the answer in the terms of BC and CE, right? So now say 10B is equal to AP by BP, that is perpendicular by base. So 18x by BP, and BP is actually BC minus CP. So BC minus CP is what? 5x. Okay, and 10B is given to us as 3.6. So 10x is equal to BC, so BC is equal to 10x. So this length is also 5x, that means BP is also 5x. Now since the two triangles, all the sides of the two triangles are in the ratio, that means CE by CP, CE by CP is equal to CD by CA, right? CE, and we want CD by CA in the terms of CE and BC, and CP will be what? BC minus CP will be what? 5x. So since BC is equal to 10x, CP will be what? BC by 2, right? So CD by CA is 2CE by BC. So here we are asked CD, AC by CD, so that AC by CD, that will be BC by 2CE, right? BC by 2CE. So a very simple concept of similar triangles we have used over here, nothing else, right? And this problem should not take more than a minute to solve, right? This entire paperwork I have done for your reference only, otherwise nothing has to be written. I think just 1 or 2 lines you need to write. Okay. Now friends, let's see this question from SSC paper 2013. D is a point on the side BC of a triangle ABC such that AD is perpendicular to BC. E is a point on AD for which AE is to ED is 5:1. If angle BAD is 30 degree and 10 angle ACB is 610 angle DBE, then angle ACB is. First of all, I just draw the diagram. Here we take a triangle, random triangle. Now this is A, B and C. After that we draw a line AD, that's AD. Then this is the point E, I suppose. So this is the figure. I just name, that's A, B, C. And this angle I assume to be theta. This angle is given to be 30 degree and this is D and this angle is 90 degree, right? And what is given? E is a point on AD for which AE is to ED is 5:1. So AE is to ED is 5:1. So I suppose this to be 5x and this to be x, right? Now 10 angle ACB. Here I take ACB as C. So 10 C is equal to 6 10 theta, right? That is given, right? DBE, that is 10 theta. So that's given. Now the problem becomes very simple. You have a triangle ABD, that is a right angle triangle, right? So in this right angle triangle, if this is angle 30 degree, so 10 30 degree will be perpendicular, that is BD by base, that is 6x, right? And similarly, or we can take, in fact we can take 10 60 degree also. This complete angle will be 60 degree, right? So that also can be taken, no problem. And then we take triangle BED. So here 10 theta is equal to perpendicular, that is x by base, that is BD, right? Perpendicular by base, this is angle theta. Now 10 30 degree is 1/√3. Now what I do, I multiply both of them. So tan 30 degree into tan theta, that is 1 upon root 3 into tan theta is equal to BD by 6x into x by BD. Right? So tan theta is nothing but root 3 by 6, right? Tan theta is root 3 by 6. If I put the value of tan theta over here, so I'll be getting 6 into root 3 by 6. That means tan C is equal to root 3. Now tan C is root 3, that means C must be 60 degree because tan 60 degree is root 3. So this angle that we have to find out, that is angle ACB, is nothing but 60 degree. Okay, so that's easy. I hope you are clear. That's 30 degrees already given. This angle is 90 degrees, so this complete angle will be 60 degree. Whether you wish to use, you can use even tan 60 degree instead of tan 30 degree, doesn't matter, or you can use tan 30 degree, right? And after that, we have considered triangle ABD. This angle is 90 degree, and we have considered triangle BED. Here this is the perpendicular, in the other case that is a perpendicular, right? So the ratio is already given, 1:5, so we can take it as 5x and x. Then the remaining calculation is very easy. The problem should not take more than 45 seconds to solve, right? I hope you are clear. Now, this problem is from CAT 2008 based on geometry. In a triangle ABC, the lengths of side AB and AC equal to this and this. Let D be a point on the line segment BC such that AD is perpendicular to BC. If AD is equal to 3, then what is the radius of the circle circumscribing the triangle ABC? Precisely, we have to find out the circumradius, right? So this is A, B, C. This is 17.5. This is 9. This we don't know. This is 3, and suppose this is actually A. This is B, and this is C. Now, what is the area of a triangle? That is, in terms of circumradius, it is ABC by 4R, right? And in other words, what is the area of triangle? Half base into altitude. So base is A and altitude is AD, that is 3. So A and A is cancelled. This is 2. So we have to find out the value of R, that is BC by 6. So that is 17.5 into 9 by 6. That is the value of the circumradius. Okay. Almost from the options it must be divide by 2 if we do 0.25. So this must be the correct choice. Okay. So again and again I am insisting on the formula for area of the triangle in terms of circumradius, in terms of in radius. So you should be very much clear about it. Okay. Maximum problems will be you'll be able to solve easily if you know all these formulae. Okay. Let's say this problem from SSC CGL paper 2013. D and E are 2 points on the sides AC and BC respectively of a triangle ABC such that DE is 18 cm, CE is 5 cm and angle DEC is 90 degree. If tan angle ABC is 3.6, then AC is to CD ratio we have to find out. I first of all draw the triangle over here. This triangle ABC. That's line DE. Okay, so this is A, B, C, this is D, and this is E, right? Now DEC is 90 degree, so this angle is 90 degree, that's already given. DE is 18 centimeter and CE is 5 centimeter. Now this is a right angle triangle. Now we have to find out the ratio of AC is to CD, that is AC is to CD. That means we need to draw one more line over here that will be parallel to line DE. Okay, so this also 90°. Okay, now 10B is given to us as 3.6, right? 10B is 3.6 and 10C can be calculated as perpendicular by base, that is 18 by 5, and that is also 3.6. That means this angle and this angle is same. That means this triangle ABC is an is isosceles triangle. Now if it is an isosceles triangle, this line, suppose it is P, AP will be, that means we can say P will be midpoint of BC, right? Now triangle CDE is similar to triangle CAP, right? Because this angle is common and this angle is 90°. So AA similarity will be there. So if the triangles are similar, their sides will be in ratio. That means we can say CA by CD is equal to CP by CE, and that is equal to AP by DE, right? All the three sides will be in proportion. Okay, now we have to find out the ratio CA by CD, that will be equal to CP by CE. As since we have to find out the answer in the terms of BC and CE, CP will be nothing but half of BC, right? So CA by CD is equal to half of BC and this. So BC by 2CE, CA by CD is equal to. Okay, so easily this can be done. I hope you are clear. Now let's see this problem. In an equilateral triangle ABC, the side BC is trisected at D. Find the value of AD square. First of all, I just draw an equilateral triangle over here. Now this is the triangle, and this is side BC and this is AD. Now I draw a perpendicular. Okay. Now what is happening over here? This is triangle ABC. This is D and this is a perpendicular, so I assume this to be L, this point to be L, right? Now in an equilateral triangle, this perpendicular actually bisects the side, right? That means BL is equal to LC, right? Now to make the problem convenient to solve, what we can do is we can take the comfortable values of AB, BC and AC, right? Since it is an equilateral triangle, all the three values will be same, right? So what I assume, the side of this triangle to be 6, right? Now BC is trisected at D, that means BD must be 2. Now BL is equal to LC, that means BL must be 3. If it is 2, it has to be 1, right? Now see triangle ALB, right? In this triangle, AL square will be what? AB square minus BL square, right? So AL square is equal to AB square, that is 36, minus BL square, that is 9, and that is 36 minus 9, 27, right? And in this triangle ALD, AD square is what? AL square plus LD square. So AL square is 27 and LD square is 1, so that's 28. So AD square is 28. Okay, now you know the value of AB, that is 6. Just put up the value of AB in the option. You will be, whenever you get 28 as AD square, that will be the correct option. So that's 9 by 7 into AB square is 36. You won't get an integral solution. 7 by 9 into 36. So 7 fours are 28. So AD square is 28 that you are getting in this option. So that's pretty simple, right? So if you assume the comfortable values of the side, it will be very easy for you to solve. Okay. Now let's say this problem based on geometry. Suppose ABCD is a parallelogram. E and F are respectively midpoints of sides AB and CD. If BD diagonal intersects diagonal AF and EC respectively at P and Q, then which of the statements are true, right? Now ABCD is a parallelogram. That means AB is equal to and parallel to CD and BC is equal to and parallel to AD, right? Now, first of all, we see triangle ADF and CBE. Okay, ADF and CBE, right? Now, this angle is equal to this angle, right? Because opposite angles in a parallelogram are same, right? So, this angle is equal to this angle. I assume this to be X and this to be X. Both of them are same, right? After that, this side is equal to this side because opposite sides in a parallelogram are equal. Similarly, CD is equal to AB, that means half of CD, that is DF, and half of AB, that is AE will also, DF will be equal to EB, right? Half of CD, that is DF, half of AB, that is EB, right? So that is, this side is equal to this side, this portion is equal to this portion, and this angle is equal, right? So that is SAS congruence, right? That means triangle ADF is congruent to triangle ECB, right? Now, so this much, this one is true in any case, right? Now, if these two triangles are congruent, that means all the corresponding angles will also be same, right? So this side is equal to this side, that means angle opposite to it and angle opposite to it will be same. I assume both of them to be Y, right? Apart from that, the third angle, this is suppose Z, then this will also be Z. Okay, now what? Since this is a parallelogram, so this line must be parallel to this line and AF is working as a transversal. So you can see this shape of Z over here. So this angle and this angle will be same as as a pair of alternate angles. So if this is Z, this has to be Z. Now just see AF and EC, right? This angle is Z and this angle is also Z. That, and both of them are corresponding angles. That means if corresponding angles are same, that means the lines are parallel. So AF is parallel to EC. That is also true, right? Now, since two of them are already true, you don't have to check for the third one but for your concept clarity, I just explain how DP, PQ and QB are equal, right? Otherwise, you can stop solving the problems further, right? All of them will be the answer. But since your concept should be clear, I just explain. Now listen to me carefully. You can see this triangle, this one, the bigger triangle, this one, that is DAB, right? Now this line is parallel to this line, right? And E is the midpoint of line AB. So EQ will be EQ is parallel to AP. That means using basic proportionality theorem. Now this E is the midpoint. So using basic proportionality theorem, BE by EB is equal to BQ by QP. BQ by QP. That is PQ. Now BE by BE by EA. Both of them are equal. So BQ by PQ will also be 1, right? BE by EA is 1 because BE is equal to EA. That means BE by EA is BQ by PQ. So that is also 1. That is using basic proportionality theorem. If this line is parallel to this line, then BE by EA is equal to BQ by QP is equal to PQ, that we have proved. The first thing, BQ is equal to PQ. Now we take this bigger triangle, that is DAB, or it would be better if we take triangle DQC, right? So same funda is applied over here. This line is parallel to this line. That means DP by PQ will be equal to DF by FC, right? Just take this triangle. That would be rather simpler. So DP by PQ is equal to DF by FC, and DF by FC is equal 1. So DP by PQ will also be 1, right? So DP is equal to PQ. Now BQ is equal to PQ, DP is equal to PQ. That means BQ is equal to PQ is equal to DP. All the three things are proved, right? So a very simple question, friends. You need to be clear with the basics of geometry, nothing else. And basic proportionate theorem we have used over here. I hope you are clear. Now let's see this problem. In this figure, ABCD is a rectangle in which length is twice its breadth. H and G divide the line CD into 3 equal parts. Similarly, points E and F trisect the line AB. A circle is circumscribed by a square PQRS which passes through the points E, F, G, H. Find the ratio of area of circle to the rectangle. Now here, friends, we have to find out the area of circle and area of rectangle. We have to find out the ratio. Now, when a circle circumscribes a square, then diagonal of the square, right? Whether we talk about SQ or PR, diagonal of the square is nothing but the diameter of the circle, right? So precisely we have to find out the diameter of this square, diagonal of this square. Okay, so first of all, what I assume here, it is given that the length is twice its breadth, right? So what I do, and these are the points of trisection, H and G, these are the point of trisection. So DH is equal to HG is equal to GC. So I assume this to be X, this to be X, and this to be X, right? So DH is X, HG is X, and GC is X. That means the total length is 3X. That means this must be 3X by 2 because length is twice its breadth. So length is 3X, breadth is twice X. Okay. Now what? We know the area of this rectangle, that is 3x into 3x by 2. Now we have to find out the area of the circle. For that we need to find diagonal of the square, right? Now diagonal of the square, that is, I just draw a fair line. Now diagonal makes this complete angle is 90 degrees, so this angle must be 45 degree. So, and apart from that, this figure is symmetric. So from this point H to G, the length is X. That means this length, that is, this length must be X by 2. Right? Now this angle is 45 degree and this triangle is similar to this triangle. That means this angle must also be also 45 degree. Right? Now if it is 45 degree, this has to be 90 degree. If it is 45 degree, this will also be 45 degree. That means if it is X by 2, this length will also be of X by 2. Right? I suppose this point to be, say, M. Right? So SM is X by 2 because HM is equal to SM since both the angles are of 45 degree. Right? So this length is X by 2. Now from this point to this point, the total length, the height or the length, what we can say is 3x by 2 from this point to this point. That is nothing but the breadth of the rectangle. Right? Again, figure is symmetric. So this length will be equal to this length, right? This is the middle line of the rectangle. So the total length is 3x by 2. That means from this point to this point, it must be 3x by 4. Right? So from this point to this point, the total length is x by 2 plus 3x by 4. Or we can say 2x by 4 plus 3x by 4, that is 5x by 4. That is the length from this point to this point. That means the total length of the diagonal will be 2 times this, right? This is what? The diameter of the circle, right? So radius of the circle will be this only, 5x by 4. Now we have to find out the area of circle and rectangle. So radius of the circle we have got. So area will be pi into 5x into 5x, pi r square. So it is pi r square, right? And area of rectangle is 3x into 3x by 2. 3x into 3x by 2, right? Cancel x, 2, 2. So this is 5 into 5, 25 pi by 3 3s are 9, 9 8s are 72. So 25 is to 72, that is the ratio of area of circle to rectangle. Okay, so that was pretty simple. You can see hardly any paperwork is required. The problem is literally conceptual. Okay. Now friends, let's solve this problem from 3D mensuration. A conical whistle with semi-vertical angle 30 degree and height 10.5 centimeter has a thin lid. A sphere kept inside it touches the lid. The radius of the sphere that we have to find out. So I have drawn a rough sketch over here. Rough diagram over here. This is the cone and this is the sphere, and the radius of this particular sphere we have to find out, right? And this sphere is touching the lid of this cone, right? Now height from this point to this point, that is given to us as 10.5 centimeter. That is actually the height of the cone. Okay, now this is the radius of the cone, this is height of the cone. So, and one more thing, this semi-vertical angle, that is 30 degree, is given to us. So what is semi-vertical angle? This angle. So this is actually 30 degree, right? Now you can see this right angle triangle. This is perpendicular because this is the radius and this is the height. So angle between the two is right angle. So this is right angle and this is right angle triangle, right? Now using these two, we can find out the radius and this hypotenuse of this right angle triangle, right? Radius means this base. This is actually perpendicular, so we can find out the perpendicular and hypotenuse of this triangle, right? And perpendicular of this triangle is nothing but the radius of this cone. Okay, now relationship between these two, r and 10.5. This is perpendicular and this is base. So relationship between this and this will be given by tan theta, right? So here theta is what? 30 degree. So tan 30 degree 1 by root 3 is r upon 10.5, that can be written as 21 by 2, right? So that gives us r as 21 by 2 root 3. Okay, so this length is 21 by 2 root 3. Now we have to find out the radius of this sphere. Suppose this is the center. So this will be the radius of the sphere, and this is the tangent to the sphere. So the angle between radius and tangent will be 90 degree. So this angle is 90 degree, right? Now this, suppose this is O, P and Q. OP and OQ, both of them will be having the same length because these are the two tangents from a single external point, right? So OP or OQ will be same. So if it is 21 by 2 root 3, this will also be 21 by 2 root 3. That is radius of this cone. Okay, now in this triangle, suppose this is MQA, we can find out the relationship between, this is suppose capital R. So relationship between R and AQ will also be, we can also find that using the same trigonometric relation. This is perpendicular, this is base. So tan 30 degree, that is 1 upon root 3 is equal to R upon AQ. Okay, and similarly we can find out the complete length OA. This OA is hypotenuse and AP is base. Okay, so base and hypotenuse, the relationship is given by cos theta. So cos 30 degree, that is root 3 by 2 is equal to 10.5, that is 21 by 2 by OA. Okay, so OA is 21 by root 3. Now you can see this entire length is 21 by root 3, that is OA, and this length is 21 by 2 root 3. That means this length, the remaining length will also be 21 by 2 root 3. Okay, so AQ is 21 by 2 root 3. So I put AQ over here 21 by 2 root 3, right? So easily now only unknown value R is there, so that can be calculated. So that is 21 upon 2 into 3, that is 7 by 2, that is 3.5 centimeter, right? So easily this problem can be solved. The important things that you have to keep in your mind over here is what is a semi-vertical angle, and just do not get confused. This is the radius of this sphere and it will not be parallel to this line. Most of the students get confused over here. They just make this line parallel to this. So this parallel line and this parallel lines, but this is not the radius of this sphere, right? So do not get confused over here. That's really important over here. So we just have a quick recap. This is the height of this cone, and the semi-vertical angle is given. Relationship between this height and radius can be calculated using tan theta, tan 30 degree. So R can be calculated. Similarly, from this and this relationship is given by cos theta. So using cos 30 degree, we can find out OA, and the third is this triangle. So relationship between this and this is given by, again, cos theta. We'll be using, tan theta. So using tan 30 degree, we can calculate the unknown value R, right? So if you're conceptually clear, this problem can be easily solved in 1 minute, right?